9.1 Translations. Okay, in this chapter, we're going to talk about changing the position of a figure without changing size or shape. And this section is on translating. Okay, first vocabulary here, a transformation. That is going to cover all of our changes. A transformation is a change in position, shape, or size of a figure. Okay, we do things like flip, okay, or slide, or turn. Some very important vocabulary here. The original figure is called the pre-image, and the resulting figure is called the image. Okay, sometimes this seems kind of backwards. And in isometry, your pre-image and image are going to be congruent. So we are not going to change the figure. We are simply going to do things like flip, slide, or turn. Okay, let's look at our first example here. Is the transformation at the right an isometry? No. Why? Because it involves a change in size. This is actually called a dilation. The pre-image, right, that's the original, and the image are not congruent. So let's pause the video and do the next two problems. Okay, these were pretty easy start to this. Are these in isometry? Isometry means that your pre-image and your image are congruent. So the first one, yes, we could either flip it across this center line here, just flip it over, or we could rotate it around 180 degrees and it would end up on the image. So yes, it is still congruent to itself. It can be moved to get there. Part B, again, yes, but this one is a flip and a slide. We flipped it over and then we slid it up, or we slid it and then flipped it. But it is still an isometry because your corresponding parts are congruent. All right. Some notation here. An arrow is used to show that your pre-image maps a figure onto its image. So we start out with the pre-image and then we say arrow, which means that it has gone through a transformation and maps onto the new image. And what we call prime notation, okay, it's a little tick mark above there, is used to identify your image points. So if we look here on our diagram, K prime is the image of K. And if we do multiple transformations, we just add another prime. K double prime would be the image of K prime. So we could go K maps onto K prime, maps onto K double prime, maps onto K triple prime, etc., etc., etc. We list corresponding points of your pre-image and your image in the same order. This is just like we do congruent or similar figures, so you know how to do this. So we see here that we have a triangle J, K, Q, and it flips over and slides to become our image triangle J prime, K prime, Q prime. Now you have to be very careful to label them in the right order and make sure you are labeling the image, your resulting figure, with prime notation. And start saying those and get used to using them. Now let's look at our example for this. In the diagram, E prime, F prime, G prime, H prime, so let's find, okay, it's the blue one here, is an image of EFGH. So we know that EFGH, the black one, is the original, and it maps onto the prime figure. So we are asked, what are the images of angle F and angle H? Well, we look at order. Angle F is in position 2 here. So F prime is the image of F because they are both in position 2, just like when we did congruent and similar figures. Angle H is in position 4, so we look for position 4. H prime is in position 4, so angle H prime is the image of angle H. So we could also write these as angle F maps to angle F prime, and angle H maps to angle H prime, right? Using our new notation. Make nice arrows. Still really not nice arrow. Okay. What are the pairs of corresponding sides? Well, order matters. Segment EF and segment E prime, F prime. We could use our arrows here. Segment FG, segment F prime, G prime. Segment EH, segment E prime, H prime. Segment GH, segment G prime, H prime. So that's easy enough. Pause the video and try the example. All right, another not too difficult one. All right, we are told that triangle NID maps to triangle SUP. So we have our pre-image, and our image. Okay, this time we didn't use primes. We just said that this triangle maps to this triangle. So we look for positions, 1, 2, and 3, and 1, 2, and 3. So we're asked, what are the images of angle I and point D? Angle I is in position 2, maps to angle U, which is in position 2. Point D is in position 3, it maps to point P, which is in position 3. And the pairs of corresponding sides, well, we just go through order. Segment NI is in the same position as segment SU. ID, UP, I went from end back round, DN, so end back round, to segment PS. Those are pretty straightforward. You just have to be careful and make sure you're labeling properly. All right. The size, shape, and orientation of a geometric figure stay the same when you slide the figure in one direction. This is called a translation. A translation is a slide. So orientation, if we flip it, the orientation changes. So a translation is simply just a slide. So some vocabulary here. Translation is a transformation that maps all points of a figure the same distance in the same direction. Now, a translation is an isometry, right? That means everything's congruent. It stays the same size. So let's look at our translation here. We have triangle ABC and everybody slides the same distance. A goes that distance to A prime, B goes that distance to B prime, C goes that distance to C prime. The lengths of the segment A prime, is the same as the length of segment B to B prime. This is congruent and congruent. We simply slide the same distance in the same direction. So let's look at our example here. We show a translation in the coordinate plane. We start with our black square here. Yours isn't quite as black. So we start with our black square here, and we move it 4 units right. So we go over 1, 2, 3, 4 units to the right, and then we go 2 units down. 1, 2 units down. This creates our image. So our pre-image, ABCD, we move it 4 units right and 2 units down, which, if you notice here, is going to create a slide. Look at that. Isn't that just a fancy little right triangle there? It's going to create a slide to here. Now, every point on this square is going to move the same distance in the same direction. So we could take point A, we would go over 4 down 2, and it would land at A prime. Point C, over 4 down 2, land at C prime. Point D, over 4 down 2, lands at D prime. And you can see that these are all moving the same distance in the same direction. Now, every point on this figure moves over 4 and down 2. We focus on the vertices because then we just draw straight lines in between them. But every point on this figure is going to move the same amount. So we can say that each xy pair in the original figure is mapped to x prime y prime, where our x prime is x plus 4, our original x value plus 4, and y prime is y minus 2, because we went over 4, that's 4 in the positive x direction, and then we go down 2, right? This is over 4 in the x direction, plus 4 in the x direction, and down 2 is minus 2 in the y direction. This allows us to write a translation rule. It says that every point xy maps onto x plus 4, y minus 2. So we are going to write translation rules. Let's look at our example. It says, what are the images of the vertices of triangle PQR for the translation? Here we are given our translation rule. X minus 2 means we're going that direction 2, and y minus 5 means we are going down 5. So first thing we're going to do is find our coordinate points. So P is over 2, up 1. Q is over 3, up 3, and R is over negative 1, up 3. So we know we have our xy values. We know that we want to subtract 2 from every x and subtract 5 from every y. So we use our P, Q, and R here, and we simply minus 2, minus 2, minus 2 on all of our x's, minus 5, minus 5, minus 5 on all of our y's, and we get our new points are image points P prime, Q prime, and R prime, and we can simply graph those. P prime is over 0, down 4, Q prime is over 1, down 2, and R prime is over -3, down 2. And we have our new image. Now, if we check this, we can see that R went over 1, 2, and down 1, 2, 3, 4, 5. That's 2 left and 5 down. And we could check all of these, and they would all end up doing exactly the same thing. Over 2, down 5. All right, pause the video and do the next example. All right, this wasn't too bad, a little hard to draw because the graph isn't very clear, but I truly believe you could do it. So we want to know, we are given the image what are the images of the vertices of triangle ABC for the given translation rule x plus 1, y minus 4? Graph triangle ABC and its image. So we have triangle ABC here, and I simply found my vertices, and then my translation rule says x plus 1, y minus 4. So I added 1 to all of my x's, I subtracted 4 from all of my y's, and I got my image points, the points for my image. Remember, pre-image is the original, image is the new one. So then I graphed those, and we notice here that all of these go over 1, down 4. Part B says, draw segment A prime, B prime, and C prime. What relationship exists among these segments? Well, you know that they all go over 1 and down 4, because that's what a translation is. Everybody moves the same distance in the same direction. Now, if you're looking at these on a coordinate plane, you should be thinking slope. Slope, right, is rise over run, y over x. These all go down 4 over 1. All of these lines have a slope of -4 over 1. All right, what's next? Oh, writing a rule for your translation. So we want to write a rule that describes the translation PQRS to its image P prime, Q prime, R prime, S prime. Well, first we need to figure out, how do we get from one point to the next? Well, we take point P, okay, and we need to get over here to P prime. Now there's a couple of ways you can do this. I'm a big fan of counting if you have a nice graph. So we can know that we move in the x direction and we move in the y direction to get here. So it's 1, 2, 3, 4, 5, 6, 7, 8. We move 8 in the positive x direction and down 2 in the y direction. We can also use our points if we want to. So x prime equals x plus some number, right? So we are trying to get to 5 equals -3 plus some number. Well, how do we get there? What number is that? 8. If I add 3 to both sides, right? 8 is our question mark number. Y can be done the same way. Y prime equals y plus some number. It's really odd not to use variables there. Y prime is 2, y is 4 plus question mark. I subtract 4 from both sides. So -2 is my question mark for y, which is exactly what we found when we counted. It can be done numerically, it can be done graphically. Either way, we get a translation rule, x plus 8, y plus 2. Our xy points, every single one of them, maps to x plus 8, y minus 2. All right, pause the video, do the next problem. Okay, on this one we weren't given a graph to map it to. You could get some graph paper and graph it out and do it, but you can do this numerically. So it says the translation of image LMN is L prime, M prime, N prime for our triangles. And we are given our image values, L prime, M prime, and N prime, and we are to write a rule that describes the translation. So the first thing I did was I found the coordinates for L, M, and N. And we said that x prime is x plus some number. So I just used my x prime. I know that my x prime is right here, and this is my x value. So 1, x is negative 6. Well, that's going to change everything. Plus 6. So this is 7. Plus 6. Go fix all these. All right, so 1, which is x prime, equals x, which is negative 6 plus some number. I add 6 to both sides. My number is a positive 7. I do the same for y. Y prime equals y plus some number. So negative 2. Let's make sure I did this right here. Here's my y prime. Here's my y. Negative 2 equals negative 1 plus some number. Add 1 to both sides. My number is a minus 1. So my rule says that points x, y map to x plus 7, y minus 1. There's our translation rule. Now we can check this for all of these. Negative 4 plus 7 is 3. Yay! Negative 3 minus 1, negative 4. Yep. Negative 1 plus 7 is 6. Negative 1 minus 1, negative 2. So this works for all of our points. So we're good to go. All right, let's look at our next example here. A composition, we know what compositions are. That's multiple, right? Composition of transformation is a combination of 2 or more transformations. You perform each transformation on the image of the preceding transformation. This is what we talked about at the beginning. We can take A and map it to A prime. A prime maps to A double prime. A double prime maps to A triple prime. Okay? In field hockey, over here in our diagram, the ball can move from player 3 to player 5 by a direct pass, or you can go from player 3 to player 9 and then to player 5. So we end up in the same place, but we use different transformations. In general, the composition of any 2 translations is simply another translation. All right. That's all the space we have. We'll call it there. In chess, the diagram at the right shows 2 moves of black bishop in a chess game. Where is the bishop in relation to its original position? So if we use 0, 0 to represent the bishop's original position, write translation rules to represent each move. Okay, so our bishop moves +4 in the x direction, -4 in the y direction. So our bishop starts here, and we're going to call this 0, 0. So we can think of this as a coordinate plane, right? And our first move has it go +4, 1, 2, 3, 4 in the x direction, -4 in the y direction. 1, 2, 3, 4. There's our bishop at bishop prime. So this is over 4, down 4. right? This is bishop prime. This is bishop original, right here at 0, 0. Because we started at 0, 0, and we add 4 to 0, and we subtract 4 to 0, and we get 4, negative 4. All right, our second translation means that we are going to move from bishop prime, and we are going to go positive 2 in the x direction and positive 2 in the y direction. This is bishop double prime. And so this is, what, 4, 5, 6. This is 6, negative 2. This one was over 4, down 4. So we saw on our coordinate plane. Well, let's check with our numbers. We take bishop prime and we add 2 to the x, add 2 to the y, and notice that on the coordinate plane graphically is the same as numerically, and the bishop is 6 squares right and 2 squares down. So if this were only one move, which a bishop can't do, but if this were only one move, we could have translated directly by doing x plus 6, y minus 2. All right, pause and do the last problem. All right, it says the bishop's next move is 3 squares left and 3 squares down. Well, we know that 3 left is x minus 3 and 3 down is y minus 3. And we want to know where is the bishop in relation to its original position. Okay, so we start at bishop double prime here, and we move 1, 2, 3 left in the yellow and 1, 2, 3 down in the yellow, and we have a new spot there, and that is over 3 and down 5 from our original position that we called 0, 0. Now, we did it graphically on our coordinate plane. We can also do it numerically. We take bishop double prime, which is 6, negative 2, and we do 6 minus 3 and negative 2 minus 3, and we end up with bishop triple prime is at 3, negative 5. So that's where it is from its original position. We go over 3, down 5, and we would find the bishop after its third move. So we did 3 transformations, which can be described as 1. All right, these are not bad. Just make sure you are keeping track of your pre-image and your image and moving in the same direction, the same distance. I believe you will do quite well with these.